So welcome to KW for July. Sorry, I was about to say August. Not yet, almost. So I'm going to be talking about Rspec3 today. Next month, Bill is going to do a presentation on the Rails API. I just got confirmation from Eric and Shan that we're good for August, so I will put the meeting announcement up later tonight. What else? I don't think I have any other news. This has Eric and Bolton is always hiring, so go work for them because they're nice. Oh, and thank you to Eric and Bolton for making the space available, as always. Does anybody have any announcements they want to make? Any events that they want to announce? People they want to hire? People they want to work for? All right. I have one. If you want to know Git command line stuff, I will be doing another presentation in August with KW-Lug. So that will be August 10th. Sorry? Me? KW-Lug. KW Linux Users Group. So August 10th, St. John's Kitchen on Victoria. Yes, go. We have a presentation probably for Ruby. We have a presentation for either September or October. I don't know which one yet. We don't have a presentation for whatever the other one is. So if you'd like to give a presentation, we would love to have you. Let's see, similarly, I've had a thought about starting like a workshop thing, like once a month, so like maybe like potentially like third Thursday of the month, something along those lines. I still haven't actually gotten to do anything about it, and nobody else has either, but if that sounds interesting to someone, mention it there's a GitHub issue for it. If more people mention it, I will actually start moving and do stuff on it, and if nobody's interested, then we won't. We'll see. That may be something you give a try. This might actually be a good topic that we would follow up on with. So to start, so I did this I've worked with Rspec for a long time. I did a presentation in March 2013 to KW Ruby using Rspec 2.10. And I did a little bit of a presentation and we did a little bit of a workshop. And unfortunately, I didn't have time to actually make the workshop properly work for this time. So I'm not going to do well. If people are interested, we can have a quick look over the kata code that we had to do an Rspec. You are welcome to have a look at it. You can find this presentation on my GitHub account. Akant is my GitHub user. The code for the slides is there, and the code for the kata is there in either. There's two Rspec presentations, and the kata is in the 2013 one, and the 2015 one contains the slides. So we can have a look at that afterwards if there's time and interest, or it can be something that we kind of leave for later. So, Rspec 2.10 was where we started. So one thing that feels like it needs to be explained with Rspec is it is unit testing, but it's not exactly unit testing. But this is more classically unit testing. So you're declaring a test. You're saying, I'm going to test this method. I've got a system under test object. This is the thing I'm going to test. I'm going to set up some stuff, and then I'm going to serve a bunch of things. So it looks like a test. It feels like a test. I'm declaring something, and I'm saying these things have to be true. So now, technically, this code is going to do all the same things underneath the code. It's going to set stuff up. It's going to set some things on the stuff. And then it's going to check that a few things are true. And this is the Rspec 2 version. But the slight difference is that it's done in a it's really only a change to how you're describing it. So it's just more like a specification. So I'm describing the class at the top, I'm describing this particular method, and then I'm saying it should equal something, and I'm specifying, after all this is done, these things should be true. So, in the end, it all does the same thing at the bottom, but when you're talking about it, it's more like a specification and less like a test. So, you can see this, and this is, it's saying should for a lot of things, which makes it Rspec2. Rspec3 changes a few things around. Actually, and one of these things is actually Rspec3. So described class is something that I learned about since my last presentation. And what that does is it just substitutes the class that you put in describe at the top, so you don't have to repeat. You just say describe class for every place where you want to say the class at the top. Obviously, it doesn't work if you're not describing a class.
Isn't the subject by default class?
The subject is by default class.
Although unfortunately, we can't reference subject inside a subject. So
No.
inside of defining the subject. So that's the
Yeah, it's actually, so what Eric is looking at is, so if you left this out, the subject would implicitly be class.new. If you left out test class, laser pointer at some point. If you left out test class, your subject could then still be defined as class.new with the parameter boot. But by putting in test class, it then lets you access all of this through a variable. So that means you can then say, my main subject is this, if this is the whole overall class that I'm testing. I need to define it because I need to pass some parameters, and I need to give it a label so that when I come down to say, test my individual methods, I can actually say, my test class, call the method, pass it something else.
That's awesome. I was like, why would you give the subject a label? I would just use let, but now I get it because then you can define the subject.
Yeah, and if you didn't need, like in some cases, so if you're testing in the Rails world, you're testing controllers, for example. Yeah, if you're testing controllers, and the execution of that you're going to describe is like running the create method, or you're sort of making a create call, or making an update call, or making a get call, then you wouldn't define the subject. You just let it be, you just let it set the subject implicitly, and then you might never reference the subject at all. But in this case, this is a class where we always want to instantiate something, and then we're calling methods on it. So actually, one more thing to point out is this style is not the style that everybody uses. So I find that with the objects that I write, the methods tend to break, or I tend to be able to split the methods to like clear functionality. So I like to describe the individual methods. But there is also a technique of describing less not going method specific, but going more to, you're describing this behavior, and it may be a particular method, it might be multiple methods, it could be other things. So that's, I've found that it's not the way that I've worked. I found that it doesn't make any sense for me, just because I want my methods to actually clearly define, do a thing. So this is kind of going towards the object-oriented idea of, I pass my object a message, and go do a thing. And I don't want to know the outside of the object, I don't want to know the details of the thing. So if at all possible, I don't want to have a situation where to do something with my object, but like pass message A, and then pass message B, and then pass message C. I would like it to be, I pass the big message, and then it figures out all the details of what it needs to do. All right, so actual Rspec3 stuff. So, is expected, expect. These are Rspec3. So you can see we'll hop back to different. So you can see that is expected is actually just a shortcut for expect and then the variable inside. And if we go back, you can see that it is being a little bit more explicit than the dot should. So the problem a problem that Rspec2 has had. Now, I have another slide that will say we'll repeat this, but let's get a little bit of code. So a problem that Rspec2 has had is the shoulds. Would anybody like to guess how the shoulds end up in the right place? You notice, so system property is a variable because it just contains an object, and you're calling .should on it, and system property could contain anything at all.
Monkey patching.
Monkey patching. Horrible, evil, awesome to have it when you need it, but otherwise horrible and evil monkey patching. So Rspec2 monkey patched the object, so that When you included Rspec3 into your program, everything gets a .should. There are probably other things that they got to. .should is the primary example. So most of the time, this would not be a problem. You know, there's probably a lot of programs you can write that don't have any methods that are .should. But if you happen to have a method that you need to run .should, hilarity will ensue as Rspec and your own code fight to decide who actually gets to define .should. So that's where. The other detail to know is that this is not actually totally brand new code. This is code that's existed, but as of Rspec3, they've started the process of deprecating and removing the old stuff so they can actually get rid of it and not support it.
You have to explicitly enable should.
You do.
Is R specify and it just like aliases to each other?
There. I have some. So this lets us avoid having to do monkey patching, and is expected. Almost kind of looks like it might be monkey patching, but it's not because it's in the context of the actual test itself. And again, all it is a shortcut that you could replace is expected with expect and whatever the subject is. And something that this kind of hints at a little bit is that being able to do this gets you what they call composable matches. So if they don't I'm not actually going to talk about that, but it's something that exists and you can look into more details. But that sort of using this technique lets you be able to chain more things, do like wars and ands, and just put more things together to make more complex matches. Actually, yeah, so maybe I guess a detail to note. This is just a straight review, and it's making use of the ability to drop off brackets in order to make it look like this. So, is expected is a method call that's returning an object. .to is a method call on that object, and it is getting the argument of equals foo. So technically, this could have round brackets around here and still be the same thing. But this is where some of the properties of Ruby you get to exploit to make it look like a domain-specific language. You can just write it like this.
And is expected is dependent on subject, right?
And is expected is dependent on subject.
So if you call the variable in other test something other than subject, the first line would not work anymore. The it
Yes.
would not work if the variable we're testing was not subject.
Yeah, exactly. And that would probably, and so that's where, so again, as Eric was noticing, it and specify are technically, they both alias down to example. Because this is, you're giving specifications and then you're giving examples. So this is effectively what you're describing in Rspec. But the reason to have the two different ones is generally so it is you're saying things about the subject, and specify is you're talking about side effects. So there'd be nothing stopping you technically from using the same one for both of them, but by using the separate terms, it makes it a little more explicit than when I say specify, I mean side effect, when I say it's a direct thing that's coming back from the object. So this is asserting about the direct result of the method call, and this is asserting about other things that have happened in the system. So this could be, if you were in Rails and you were testing an active model, it could be, when I call this method, it should return, if it succeeds, it should return a true, but then it should have the side effect of doing certain things to the database, and this field should have this value, this field should have this value, and this model should be persistent. Something along those lines.
And then you should remove those parts so that you don't have side effects.
If at all possible. Although when you're dealing with models, that's usually not possible.
I just...
You isolate it all down into your model. So, we are up to, Rspec 3.3.2 is the latest release. 3.4, I believe, is that it already has changes marked in. and they're waiting to go. So as I said, it's largely cleanup. It's largely removing old things and deprecating existing things. But it does mean that there are big changes to go to Rspec3 just because they take out things that you could be using. So that lots of changes point, I will click on it. And let's see if it actually, yeah. So I was going to take a screenshot of this and try to put it into the slide just to show that there's lots of changes. But there's lots of changes. So I took this and I sliced out all the things since 2.10, and the image was still too big and too awkward in order to put in. So there are lots of changes. It is mostly like bug fixing and cleanup and performance improvements. But the Rspec team has been doing an awful lot of work. So, all right. So, and as we already talked about, slightly out of order. Part of the idea of this is to remove monkey patching. So to make Rspec entirely things that get called on your objects and to not do any direct manipulation of your objects. So this is their tagline from their website, and I like to put it up because it emphasizes something that I hinted at the beginning, that even though Rspec is technically, like you're doing TDD with it, that's kind of what, like that's what the tool is for. But it is behavior-driven TDD, so it is, so unlike if you were using something like Minitest, which is another testing framework, but that's more test-focused, you're putting yourself in the mindset of specifying behavior, which also hopefully moves you to the mindset of test-driven development is being done for the purpose of design. And that you are doing it so that you get better objects and better design, like cleaner code, and not primarily that you get tests. Tests are basically just, regression tests. It's pretty convenient. It's really nice that through this design process you get tests. But the idea, the primary thing is not that you get tests, but that you get nice object-oriented code. And the pain that you feel from various things you do in TDD pushes you towards a lot of the good, well-accepted object-oriented principles. So, we also hinted at this already. So readability and aliases. A bunch of the stuff that Rspec does is all about readability and just being able to say things in the way that makes the most sense. So that means you have aliases for a lot of things that turn out to be the same code underneath. So describe blocks and context blocks are actually the same thing. They're just underneath the covers, they're example groups. And this is where you're grouping together setup and specifications. So you're grouping together a block that says before, do some stuff to set up, let these things be true, and then a circle some stuff. And so again, technically, the compiler, the Ruby itself, won't care if anything you do is describe or context. It'll only make it more clear. It'll only make it more clear to yourself and your other future developers who are reading it about whether I'm describing this method here, and the next thing is I'm describing the context where I pass it X. Here's the context where I pass it Y.
I don't know if you do this, but I use describe the name of this method, and then the context, like for example, if I was trying to describe a validation, I would say context when email is invalid, it should return false. And what the method I'm testing is not valid, which would be described. So the context, I always use it as like when, basically almost always context starts with when. The string I have to attach to context is when. Like context when thing. And then context.
Yeah.
I don't know if that's it.
I have not been disciplined enough to actually get good English names. Like to get good, like actual proper English, like if you string it together, it'll turn into a good description of the test. But I do effectively the same thing. So like in Eric's example, you could have like describe the method, and then you have one context of invalid email address, one context of valid email address, and something else went wrong, and then a third context of valid email address, and everything went well, and this is my good case. And you, basically, it's called context scenario could be like another good word for it that you're describing here in the various scenarios that my code is going to go through. So, and then similarly, you've got it, specify, and they're all equal to example at the bottom. And so, as I said, the general practice is that it is for when you're describing things about the subject. So, I run this method, it should be true. It should be false. It should return this object. It should, even like it should have some property. So like if you're returning like a model object, say it should have a .name field, and that .name field should equal foo. You know, it can be more detailed, but it is generally there is the practice is that it should be for the actual subject, the thing that's getting returned from your execution of your subject method. And then specify is for side effects. So I do a thing happens in a database. I do a thing happens on the file system. So it does mean it helps you give an idea of, you know, as Bert pointed out, that if you see specifies, it may be a place where you want to look for, is there a way you can avoid doing that as a side effect? If you can turn it into somewhere else where you can make the result that's coming back into a direct result of the method, then it makes your code simple. So again, it's that process of like just driving you to better designs. And by knowing when you use specify, it should sort of stand out it should stand out as a flag. And so that if you're, so for example, in my own code, so the database is a good example where specify is pretty common. So I know if I have a specify inside the description of my model, that's probably okay. I run a method and then I want to verify that a bunch of things are true in the model. So for the way that I'm testing, that feels okay to me. But if I just have like a straight Ruby object, I probably don't want side effects most of the time. And if I see a specify anywhere else, it's probably something that I would rather not have if possible. Questions? Does that make sense?
Too bad we couldn't just write code that never spoke to a database.
It's true. If there were no databases at all, it would make things quite a bit easier.
No databases or file systems or real people using the system.
It was just all beeps and boops inside the computer would make it much easier.
Well, so another area where I would assume that you do specify a lot is if you're testing your controller.
Yes.
Because really it's all about the side effects of updating the model.
Yeah.
Right?
I mean, unless you only tested that your controller returned 200s, which
Yeah.
would be
Yeah.
not very useful.
Well, and which actually can be depending on how you write the matchers, can be another example. So I'll do, so when I do my controller test, I'll use its for the direct responses from the controller. But then I'll use specify for like verifying that, you know, after all the stuff happens, that this variable that's going to go to the templates is actually set to the object that I expect. So that it'll be specify assigns this particular object. And I'll treat that as more of a side effect than the direct result of the controller. Should have treated as the result of the controller is the HTTP response, and everything else is a side effect. And then again, it gives you a separation in the test of here's my its that are the direct responses, and then here's my specifies that are other things. And you should probably reduce them as much as possible. But so then we have a question of what should we describe? So we talked about how my usual technique is to describe methods. So a common practice that has come up has been that you use dots for class methods, you use the pound symbol for object methods, and then sometimes you describe things that aren't directly methods. So, for example, if you're testing a controller, describing the update, create, get, it's kind of a method, but you're not testing that method directly. So, I won't usually give it the method notation on the front. And then, similarly, if you have so this might also be a smell. So if you have a method, or sorry, if you have a class, there's a bunch of methods, and you have a bunch of methods that are kind of related to each other. Nothing's stopping you from sticking them inside a describe group as well. Just thinking of another indication, these things do things together, and maybe you're going to do some setup for them. So I'll use this if I'm doing an active model. I'll do this for scopes. And I'll set up, so I'll describe scopes. Maybe I'll do some coding here that sets up the database, because I might say that I actually want to test my scopes or defining either actual SQL or actual queries against the database. And in my work, I've been finding that testing those queries right in the model right here and nowhere else has worked pretty well. So this would be the place where you can say, like, do the heavy lifting to set up the database, and it only happens for these. And then if I had other methods down here that aren't touching the database as much, it doesn't happen for those things. And again, it gives you a nice, that if you're printing out your Rspec documentation, you'll actually see this. This text will actually show up in your description, so it will make things more clear for you. And again, these are just example groups. So they're nested example groups. They're actually exactly the same thing. You could put context in here, and it would be the exact same code, just way more confusing. And here is, I guess again, what we've already hinted at. So this is, I want to describe a method, and then here's my first situation, here's my second situation. So when X, do some setup, and then I say these things should be true about the result after it happens, and then when Y, do some stuff, and these things should be true about the result after it happens. So there's another name for these in the QA thing that I can't remember. It's not. I don't think it's scenarios. It's cases. Might be cases.
Use cases.
No, it's not quite use cases. I think it's lower on the. It's lower level than that. Anyway, there are lots of different words for everything. But yeah, so it's defining each of your cases. So in some ways, it's a depending on what you're doing, you may effectively be building like a little matrix of this is true, this is true, this is true, this is the result. This is true, this is true, this is true, this is the result. And for some things, it may end up being effectively is just a table with all the permutations of the things that you have to say and the result that should come out. So, but you can get carried away. Get away. So, this is so many things are, you can do it, but it's probably an indication that something is too complicated. So, you might end up needing to do this because you actually have a situation where there's a whole bunch of variables that go into your method, and there's a whole bunch of if statements inside of your method in a whole bunch of different situations. And you actually have like some special setup for this, some special setup for this, and some special setup for this. And you can dry your code out by having a huge number of nested contexts of nested situations. And that's good, but it's also terrible. Because now in order for someone to understand like the thing that you assert here or the thing that you assert here, they've got to read through and see, okay, well, we do a bunch of stuff up here, and then some stuff, and then some stuff, and then assert that something is true. Which is much more complicated than if it was just, here's one list, I read these things, and then I see the thing that should be true. So, again, it's an example of something you can do, but it's probably an indication that you need to break stuff into more objects. You need to separate out, you need to take, the stuff that happens in here, make it its own object. Then you test it separately. All this has to say is, just checks that you ask the object to do the thing, and then it comes back. But I test the thing over here. So again, I guess it's another good example of the design aspect of doing this. That as you do this, you do some things, you feel some pain, and the pain means you should stop. You stop, you break things apart, and then everything is done. All right. So moving on. So this is the place where we're defining variables. So the lets and Rspec are effectively global variables. but they're lazily loaded, or at least they're lazily loaded some of the time. So the top one is lazily loaded. So this is a method, this is the parameter to the method, and this is a block that gets passed, and that block gets executed. So this now lets us call variable within the test, and the first time it's called, it executes that block and returns the result. It then means that we won't execute that again. It'll only get executed the one time, so we won't have the cost of executing it multiple times. But it also means we won't execute it multiple times. So yeah, there are trade-offs. There will be times when you don't want to do this because you actually want something to run multiple times and you want to see what happens if I execute this thing multiple times. Mostly that won't be true. I found that this is usually worse. So that does that, but then the thing that can trip you up, if you are working with side effects. So the database is a very good example of where you might be working with that, where you don't want it to be lazily loaded, and you actually just want it to be set up right away, because there's a thing about the database that you need to be true before your test can function. And the let bang will just execute it right away, but still make it accessible in your variable.
That's still only run once, right?
It'll still only
Still
run
just once, it's not lazy.
Yeah, so this will execute. It will run through all the befores. I think it'll actually execute before all your before blocks for each one of your tests. It'll execute the let bangs, execute your before blocks, and then do your tests.
I found the let bang to be particularly useful if my subject is create, I don't know, a user, and I have a test that says expect user dot name to equal something.
Mm-hmm.
There's the odd, it's not specifically that case will probably work, but there's this odd way where you're making something in the database and you assert something on it, but you have a easily loaded variable, and the get test failures will expect it to.
Yes.
So sometimes, if I'm having those problems, I just put a let bang.
Yeah.
Makes the thing.
Yeah.
Like that test says.
It can be kind of a hammer to just get things working. But actually, so for that example, it would be if you were defining a user and something had to exist in the database. So say all your users had to belong to a certain country, and it was going to pick out a country by default. It was just going to be whatever the one is in the database. You could lazy load, you could use let bang, say equals country dot create Canada, and because it has the bang, it executes it right away. So it puts one country into the database, and then you execute your user object, and it picks up the country correctly because it's already got written into the database. But then this assumes that you want, so then you would maybe want to be able to assert that Canada was the country that got picked up by the user, and then because you've got a variable, you can then say expect user.country is equal to country.
That's exactly the case that I was thinking about. When I want to assert something about something that should have been created, but I didn't create because it's in a lazy variable.
So it's an example of you could, we didn't even slide. This is an example, it's something that you could put into a before block and just have a piece of code run in your before block. But if it's in the before block, then you don't get it in a variable. So the decision would be, if you're going to do something with it, you put it in a let bang. If you're not going to do something with it, you can just put it into the before. So here's an example of these. So again, the database, talking to the database makes a good example for setup and side effects and things that you need to do that are sort of outside of directly dealing with the code. So this could be, before I do all my tests, clear the database. Just, wipe everything down to an empty database and my test will do all the stuff. Or similarly, do something to the system. So I'm testing a piece of code that goes to the file system and retrieves something. And I want to make sure that whenever I run this test, I set that property of the file system first, and then I validate that my piece of code actually goes out and gets that thing from the file system. And so in this case, there's no result that we're going to do anything with. All we care is that the code ran. So we don't need it to be a let bang with a variable. We just need it to be a before. So again, it would be, it's another example of, at the bottom, it's all the same thing. It all runs the code before you do anything else, it sets everything up. But this is telling your reader that I don't care about the results, I'm not going to use them. Whereas the left bank says, I do care about the results. You know, later on in the code, you're going to see me reference this. And there's some extra before and after things that I've never used. They exist. I could see if you were doing database stuff, they might be useful. Actually, no, I sort of lied. I have used before each. Well, before each is technically, yeah. So the each is implicit. So all the befores are technically before each. Generally, there's no reason to be explicit because it's probably the only one you're using. Before all, I think I've made use of that in the configuration. So like when I start my entire suite, you know, set up the database, make sure I can connect to the database kind of thing. But that's it. In an individual test, in the stuff that I've done so far, I've never found a good reason for it. But it is there because there's going to be situations where that is useful. Similarly for after. So after you could use for teardown. In my experience, I've found that I rather do that kind of stuff on my before. So like run the test, leave stuff in place, and then just delete things, or you know, have code that verifies that things are deleted before it runs the next test. I find that's usually good for like being able to look at the disaster after you run a test, like does things on the file system, as opposed to just like cleaning up. It was like, hey, a bad thing happened, and I deleted all the files, so I can't look at the bad thing that happened. Okay, not so good. But if you were doing like an integration test where it was, you know, spin up a daemon that does an expensive computation or use a lot of memory, or I don't know, an integration test that spins up AWS things, and then you want to spin them down after your test, you should probably question why you're doing a test exactly like that. But
you can put expectations in there as well, can't you? I'm pretty sure you can. Because occasionally I run into like when I'm using context blocks and everything, I want to assert the same thing over and over and over. And so you could say expect, again, I'll use validations, like expect subject in and after, expect subject valid to be true. Whereas all I'm changing is the context, like defining all of the valid things. I think you can do that.
that's actually
Some people might not agree that that's a good way to go about things, but I'm pretty sure you can. And same thing in your befores, I'm pretty sure you put expects in it.
Yeah, which I guess in your befores would be, you'd be expecting things about the system before you run any of your code. But yeah, it is, so it is all just, it's all just example groups. So you can, all the code just present in any of them is present, or any code just present in one of them is present in all of them. The idea about running some expectations in the after, that's actually kind of interesting. Because I know like for some, so yeah, like some database stuff, you're mostly, you're validating, you know, if you make a group that says, here are the failures and here's the success. And if you've got a couple of success scenarios, there's lots of times where it's like, it should be persistent and like these 5 elements should always be set. But then there's these other elements that may vary. So that would be an interesting idea of using after each to actually check the persistent and the common elements, and then each of your individual tests can verify the things that are specific to each scenario.
How do database transactions work? Like, is it just kind of like wrap everything in one transaction and then rolls back when it finishes, or is it per?
You can pick a strategy.
Yeah.
What's like the default, or what's like a common one?
I don't think there is actually a default one. Database Cleaner has been the gem that I've been using, and I think for when it's doing SQL, I think it defaults as a transaction. Yes. So I think transaction, truncate, and there's probably other ones for different databases. But yeah, so the Database Cleaner gem.
Okay. Best practice is probably just like run at the beginning, like, or.
Yeah, that's what's been mine.
Yeah.
And actually, and so that's an example where I was saying, like, calling like before all at the beginning, like, you know, call one database clear before all, so before anything happens.
Right.
You know, one big database clear, to make sure that I've got my database set up and it's initially clear. Well, and even before each one.
You can do that in the test.
You can do that in the test, but if you know that you're going to do it for, well, if you know you're going to do it for every single one, or if you know you're going to do it for this specific subset of tests,
Right.
you can add, so something that I've not covered here, you can put tags on your individual tests. So you could have something that only runs on tests that are tagged as database.
Right, I got you.
And then it could do database cleaner, you know, clear it in your appropriate strategy, and it guarantees you've got an empty database before you get started. Or I guess the more complicated example might then be if there are things that have to be set up for every single test, and they are potentially expensive, would be where your transaction strategy might come in. Because it could be before all, do the expensive things, stick them in the database, then
Right, right,
declare a
yeah.
transaction when you get started next, then you roll back and the expensive things are still in the database.
Eric, you're saying the test helper, like, you just want to clear the database before everything runs, like you were to put it?
Yeah,
Rather
there's,
than,
you can definitely do that. Like, you can set the strategy in the test helper, and then you can, like, if you're using database, you can also do that there. Or you could just load a bunch of fixtures with the database and keep adding stuff to the database and then delete anything and just run your test that way. That's the way the project that I have currently inherited does it, and it still works.
Yeah. So you could do it that way, but.
Yeah. Good attempt.
Could,
Yeah.
And then you will find an unexplained failure that doesn't fail for anybody else.
You can maintain your fixtures files forever.
Yes. And after you finish banging your head on the table, you will never ever do that again. All right, so a lot of the stuff we've talked about so far, like we've talked about side effects and things where it's useful to the database. But so in the work that I've been doing, I've tried to limit that code to the models in our Rails project. So make sure all this stuff that talks about database exists in your models, you test it on your model, and then whenever you're testing anything else, you talk to mocks or stubs or doubles of those models. So all you're verifying is here's the user object, I run this controller, I told the user object, create with these properties. My controller test doesn't care about the details of create. All it trusts is, if I tell the user create, it responds with the thing that I expect. In some scenarios it raises an exception, in some scenarios it just says, yep, okay, fine, I agree. That's where mocking, stubs, and doubles come in. So, Rspec2 had mock and stub, which were, I think they might have been subtly different at one point, but then I think at some point they weren't actually different, they did the exact same thing, and then they realized that these are the exact same thing, we're just going to call them double. And I think the double terminology, I think that might have been Martin Fowler or somebody else who came up with that a few years ago as a way of sort of taking mock and stub and just smushing them together and declaring that the differences between those two things don't actually matter. So the double creates an object which will pretend to be whatever object you have. So you can pass it a string and it'll give you a label when it gets printed out. You can also pass it a class, but when it's just a regular double, what you pass it doesn't actually matter, it doesn't do anything. In this case, the double is automatically defining a method called field that will always return a double. So this would be a good example of, something like that would generally be good for mocking a model object, because you probably have a bunch of fields and you just want to say, when I ask for the name, give me the name value so I can check to see that it showed up in the right place in my control. But the double doesn't actually do anything with this. So we've got two new things. There used to be a gem called Rspec3, which did this and it's been pulled into Rspec as a 3. And what these do is they actually verify that the methods you define exist on the real classes. So this helped solve the problem of I locked my methods over here, but then I changed my real methods, and nobody ever went back to check, or nobody ever went back to adjust the mocked methods. And all the tests that use the mocks still work. And if I don't have an integration test that runs the whole thing, actually executes things, or I have an integration test that executes most of it, but they missed this one method that I just changed, yeah, everything's terrible. But what this will do is this will actually throw an error. If in real class, field doesn't actually exist, when it executes the test, it'll throw an error before it does that. And the same thing for class double. It'll look for a class method of class method, and if it doesn't exist, it'll just throw an error right in. So it can be a pain in the ass, because now it'll throw more exceptions than it got before. I recently did a conversion and added as many places as I could. It was a bit, it was a little bit fiddly, but it was nice because I've run into this error specifically before. Now, the place where this won't work is if these methods, if a method that you're calling is getting dynamically defined at some point, so it doesn't actually exist for Rspec to look at the method and check that it exists. The fog library is an interesting example of this, that you'll have one of the objects that defines one of the virtual machines that you're defining, but all of the methods aren't defined right away. You have to load stuff in a certain order before all methods show up. So this doesn't really work on those lines. But the vast majority of objects, when you haven't done goofy Rails stuff, they'll probably work, they'll probably be helpful. So the general best practice that I think is probably right now is, unless you have a good reason not to, you should probably use instant double and class double, and they will probably save you more pain than they will.
Those aren't keywords, right? Like field and class method. Those are like field is a method called field, and you want it to return a value.
Yeah, exactly.
And same thing with class method.
Yep. And those are just for arbitrary strings.
Yeah. When I first saw it, I thought class method was specifically the class method of value, but
no, it's actually the class method. I probably should have chosen something a little more arbitrary for that. But yeah, and again, this is effectively just shortcuts for something that will show on our next slide. And then this one is, this is Rails specific. This is defined it's actually been broken out into another gem, but it is at the top left, it's in the Rspec-Rails gem. And this defines mocks and stuff that are specific to active models. So the mock purely defines methods that are on the model. I always forget. So these are slightly different, sort of in the same situation as here. Slightly different, so I always have a hard time remembering exactly what. My easy shortcut is I usually just use stub. So stub, right, hey, I wrote it down. Sometimes I'm smarter than I think. So, mock model is actually just a double. Stub model is an actual instance of your model plus stuff. And the main part of the stuff is that it disables writing to the database. So it'll sort of act as if it's basically the object saying, yeah, I'm fine, no problem, don't worry about it, I'm a real object, but it won't actually do anything in the background.
but you can tell it to.
You can tell it to, so you can call all the methods, you can call all the fields. If you call a field, it'll return like your usual expected default value. You can set a field on it, you can set stubs on it to just return arbitrary stuff. But when you call .save, it won't actually go all the way to the database.
But .save, will it return me true or false based on my validations, or will it just always return true?
I think it'll just always return. No. I think it will run the validations. Because there is, like, if you read the docs, it describes, and I forget the method, there is a method that specifically overrides to avoid writing to the database. And I think that comes after the validations. So, it's most of the time when I'm doing database, I'll use stub model because it generally does what I want. And the two of them hurt my brain. So the stuff so what was just getting set on the stubs were just expectations. Basically, they're shortcuts for allows. And this is another example of unwinding some of the monkey patching that existed in Rspec. So previously, this would have been done with a .stub, and this would have been done with a .should, actually defined on the object itself. But now it's, again, sort of similar notation to the expect that we saw before. You call allow around your object, that returns an Rspec object that we don't directly need to worry about, but it has a to method, and then that to method accepts some more stuff. We can then describe what we want our method to get. So this is we're going to use this for when we've got a more complicated method that we want to call. So I want to make it possible to call the method with this argument, and it's going to return this value. Whereas, so for example, when we just did the basic stub, it was call the method, return this value. Don't take any parameters, don't do anything else, just return this value. Whereas here I want to say, so it could be, I called the method, passed in some variables, and I want to make sure this method can be called, and after some processing, it passes in this argument. But so now allow doesn't actually verify that it's true. It might happen, it might happen, it might happen once, it might happen 5 times. The test doesn't actually care. The expect, however, it cares very much. If you get to the end of the test and it hasn't hasn't seen this method get called with this argument, your test will fail. There is a bunch of extra notation where you can specify once, twice, number of times, and various things about how often it gets called. But as with the default one is just that I expect this to be called exactly once and no more. And with this argument, and it returns this result. So these can be useful. So this is, should return this, and then you verify that this result gets passed around some other places. So this could be, I want to verify that this result gets returned by the method that I'm testing, for example. And so there are other things that you can have your test methods do. So these are doing the same allows. The graph is tightly like would have liked. But so we're saying the same allow, we're doing the same allow on this object. I want it to receive a method, but this time instead of returning a value, I'm going to raise something. So this would let you test error situations. So it means you can avoid having to set up an error, so you don't have to make the database into a certain situation that causes an error. You just say, magic, and an error happens. You could do a similar thing with and throw, which this is very interesting. I've never actually used this. So there's catch and throw notation in Ruby where you use catch symbols. So it's not intended for errors. It's just intended for different kind of control flow.
Like quick return stuff to context or something like that.
Yeah, exactly. I think that's used in Sinatra when you call, like when you finish running a controller section in Sinatra, you will call what? I can't remember. The routine where you end and you say, oh, sorry, when you say header, I want you to return this response code in HTML. And it actually uses the throw and catch stuff to do that, to just, okay, you told me header, I'm done. I will throw up a symbol that says what you should do next, and it'll continue on. And so similarly, you can raise errors, you can throw, and you can yield. I've been using this one recently. It's really interesting, but it's also really fiddly. So if you're testing something where you've got this method and you pass it a block, and the block does a thing, and you want to verify the thing that happens inside the block, this will execute the block and pass in whatever parameters you specify to that block. So and then you can have other expectations to verify that the methods within that block are called appropriately. Again, it's one of those things. I found it makes the test a little bit harder to understand because it's a bit more fiddly. But it's really useful to have it when that's what you actually have to test, because it's kind of, it would be worse if you didn't have it, because then you'd have to figure out some way of kind of faking that. Or again, you'd be back to the, similar to the generated error, back to the, oh, I have to arrange my database in just the right way that it will think that's an error. And you don't really want to do that. You want to just say, if I want to test an error, I can just return me an error and I'll trust that underlying thing, but that I've tested the generation of that error somewhere else. For the test where all I want to know is what happens when an error happens. I just want to make it happen. So that's recruiters.
So in this case, on the bottom, you're saying that when double receives food, it's going to pass 2 and 3 as the arguments to a sub block.
Yes.
And sub block, like a block that food comes.
The block, yeah. So actually, again, so every time in a presentation, when I have noticed whenever I see that I'm telling people to imagine something, I realize it's actually I'm missing a slide. So I should have, so the code we're testing here would be method, and at some point it calls food with a do X, Y, and then a block that does something.
Okay.
So this is saying, when you call foo, execute the block that has been passed, and pass in the values 2 and 2. So that also means this will complain if it doesn't have a block, or if it doesn't have, the block doesn't have 2 parameters. Or if the block doesn't have more than 2 parameters. I think it'll fill in nils for additional parameters, but I don't remember exactly. But yeah, so that's a nice example, an example of where I need another slide. So, this again. So these are shortcuts for doing the same things, but just to make it easier. So receive messages is pretty straightforward. You're defining multiple messages. So this is doing the same thing that we were doing in stub, where you can say stub, field value, field value, field value. This is doing the same thing after the fact. So any given object, define things. Now, one thing to note is because they have separated the receive call with the allow and expect, you can expect this. So if you know, guaranteed, you're going to call method 1 once, method 2 once, and you like part of verifying the test is that these things will be called and they will return these values, you could just use expect. In what I've done, I found in a lot of cases that's not what I want, because usually I've found this structure is for I'm defining, this object has this property, this property, this property. They're just returning data, so all I want to do is make sure that these values are available and they'll be called some number of times. But
I've got a real world example where I've got a form object that you put in your height, but your height is put in feet and inches, and they're 2 separate fields.
Mm-hmm.
So that has to calculate a height in inches total at some point. So something like that would be what I'm looking at.
Yeah, and you could have something, I want to verify that, yeah, you definitely call partial foot, you definitely call partial inches, and those are used in the calculation. So that's, so you're defining multiple methods on one object. That means something slightly dangerous. So, this is a message chain. So this is for defining, I want to call double, and I want to call double dot method 1, and then I want the dot method 2. So I want to call these methods in order. I'm not passing them any extra parameters. I'm just calling them in order. So this could be useful for like Rails models where you've got criteria or scope objects, and you don't have to pass them any extra parameters. You just know I need to call this one, this one, this one, this one. But this is so dangerous that the Rspec documentation specifically contains a warning that you may be getting yourself through trouble and references the law of density, which is, so the example, so the Rails example where you're just doing criteria objects is not a law of Demeter violation because they're all the same object. the law of Demeter violation comes in when you are talking to a bunch of different objects and you're chaining them all around. And so your calling object now knows about all the implementation details of your internal objects.
That seems.
Yeah. So this it's basically that message chain makes it easier for you, or makes it less painful for you to do this, so you can end up doing something that you probably shouldn't. But like Rails criteria or active model criteria are an example of where it's really nice to be able to do it. And what I want for this,
String operations.
like for string operations, yeah, you actually want to chain a whole bunch of things. And what I really wanted was like a picture of a statue of Demeter, and I wanted to put googly eyes on it, and like looking at you, like what have you done? But I wasn't able to get that picture working. Maybe not.
Close enough.
Yeah. So like here, but so this was supposed to be just an example, which also didn't wrap as nice as it could have. So the top one would be like the Rails, the active model criteria objects. So each of these methods is returning a criteria object, so you're not actually violating the law of Demeter because it's all operating on the same object. You're not giving any new information. You're not exposing any new objects each time you go down the chain. This one, on the other hand, so you're getting like the list of salespeople or the collection of salespeople, which then you talk to the orders, and then you look at the address objects that are on your company object at the beginning. So you talk to like 4 different objects. So if you change any of these in the middle, everything's going to go terrible. So, but what you want is, this is where law of Demeter tells you, just give this a name, say what it is, and then you can collect it together. So this could be, get me the addresses for all the open orders for this company. Then when I test it, my test can just say, verify that I got the list of all the open orders, the addresses for the open orders, and these details get moved down where they can be a bit less complicated. So the thing to keep in mind that as much as it's called a law is a terrible name for it because it's a code smell, and you can make your life more complicated by being too strict about it, because you can end up with like a ton of really small methods that don't actually add a lot of value aside from separating things out. So I have found that applying the law of Demeter is frequently the kind of thing that you might start and like chain 1 or 2 things, and then you realize when it's causing you pain, or you may have chained too many things, then you start to break it down in the appropriate way.
Can you explain? I mean, we talked about the same collection, but I found this confusing when I first got the law, or read about the law of Demeter. That the second one did not really look different to me than the first one. So what is the difference in the first one that, aside from like using the same object, that doesn't really mean anything to?
So it's not the same object,
Well,
it's the same class.
Yes. And
Yeah.
so why can I chain in the first case and not in the second case?
Because so I guess the critical part is information hiding. So that I am trying to minimize the amount of information that is exposed between objects. So in the first case, all of the objects that are involved are active model criteria objects. So by chaining them, I'm not exposing any more objects. I'm not requiring that I look through, I'm not requiring this to understand any additional code in order to be able to run it. I think that makes sense. There's also a very technical definite, like there's a technical, like specific mathematical proof of why this makes sense, and that's really hard. But so yeah, so the first one is all the same object, which is what makes it more okay. But then in this case, it's supposed to be that they're all different objects. So if I change any of these individual objects, then something different will happen, and I will have to go back and verify that all the places where they get called are actually doing the thing that I want. The other thing that I've also found is a big benefit is just the label. So I guess again, it follows an idea of sort of encapsulating things into methods. So, if you were going to have a chunk of code and you're going to put a comment on it, that there's a good chance that that chunk of code might actually just need to be a method with a name on it. I've found that this is kind of the same thing. This is the details of what I want, but what I actually want is give me the open addresses for the orders. That's the concept that I want, and the chain is the detailed implementation. So hiding away the detailed implementation from the code which actually just wants open order addresses, simplifies things, hides information, and then it makes it possible to change the details of that without changing all of the code. It's just looking for, I need a list of open order addresses. I don't really care how to get it. I just need you promise to give me back an array of address objects. And if you do that, I'm happy with calling code. I don't need to know that you go through these chains. I guess the canonical example is like if you've done this a bunch of places and then you add something in between your salespeople and the orders because you've adjusted how your database works. If you've got this kind of method, then you change it in one place. If you don't have that kind of method, then you change it all over the place because you have to hunt down all the places.
But in the top one, right? So I'm not asking these questions to like bother you guys. I'm just like in the top one, I'm assuming that some other code is calling this is an internal code to the customer class. The other code still knows an awful lot about customer, or specifically, it knows about customer and it knows about the active record interface because full money is probably a scope. Everything else is an active record interface. But the one key difference is that if they're all conforming to the active record interface, we know they're going to return something that also responds. Where is going to return something that responds to sort by? That's the benefit of having the same class be returner. Right? Is that I know that if I have another instance of the same class, it responds to the same messages as the previous thing. Whereas these are all different classes, and so
And they change at different rates. But you also make a good example of if you do this, there's probably a good chance that you actually just want to you still want to encapsulate that into a thing which describes what it is.
like customer owes money,
Yeah.
owes the most money
Yeah.
or something.
This is the list of customers to call or email.
Yeah. People whose links I need to make.
The customer on any list.
Yes.
I think my principle on that is always write the code like the next guy is a serial killer.
Yes.
And has your address.
Yeah. That's what I've always said. They know where you live.
Yeah. So again, I mean, it's all. This is again where all of this stuff is. There's almost always no hard answer. It kind of depends how complicated is your code base. Are you going to come back and look at this again? If you were just writing a script that you're going to look at the database once, just don't worry about just abstracting stuff away. If this is in the product that you're hoping to use for 10 years, yeah, you probably want to think about abstracting a few things away.
Or you can deal with it in 3 years.
Or you could do it within 3 years. And it's like, who wrote this code? Damn it was me. Worst thing ever. So, and this is an example. You can do the same. So the sorts of things that the chain method was letting you do, you can do manually if you've got more complicated situations. I didn't rewrite this in fancy Rspec3 method. So a quick walkthrough, but generally it looks horrible. This is horrible. This would be an example of like you're doing this because you need this to work, but you write a whole lot of stub code, and you feel the pain of writing the stub code. And if you could, you'd rewrite it. So you've got a model. You call a method pass an argument, a method pass your argument, and a method pass an argument. So what you need to do is stub each model that's getting passed, and then let that nest inside so the model that was called, or the object that was called previously will accept the next method. But because you're passing parameters to each one of them, you also have to pass the width, and it's a nightmare. So you Model 2, it returns your final result. And then Model 1, you call your method 2, you've got your nested model, it returns your nested model that you set up here, and then your final top level model, which receives your first method and returns your first nested model. Ah! It's horrible. But, again, it's the fact this is not that many characters. You could write this pretty easily. You wouldn't feel a lot of mental anguish, a lot of mental pain writing this the first time. As it was like you've got the whole system in your head, you know what you're doing. It's okay. But then you write this, and you realize, like, oh, it's totally not okay. I should not actually write that. If possible, I should stop that. Or I should think more about this. And it's like, okay, yeah, for this situation, I actually need to write, I actually need to chain it like this, and I'm not using it anywhere else yet, so there's no point in abstracting it away yet. But the next time I come back to the code, this is a big, nasty warning sign that says I should probably try to do something different. If I'm using it anywhere else, if I change this code on a regular basis, if my coworkers start throwing things at me. So, refactor. As you see things like that, you know that it's either something you need to refactor right away, or something you need to refactor soon, or this will be a signpost for when you come back and touch this code. It is terrible, and if you are maintaining it or reusing it, then you should refactor it before you do more things. And then, almost finally, we have, so setting the expectation. So at the end of our spec, this is the stuff that we had at the very bottom. So using is expected as our shortcut for expect. There's so this, its notation used to be a part of Rspec directly, but it's now been broken out into a separate gem. So if you want to use it, you just have to include Rspec-its as your gem and Rspec/its as the library. And what this does is it implicitly grabs this method on the subject function. So this would be equivalent to something else. Imagine, if you will, that I had another slide right here.
Can we stop to change the battery?
Oh, certainly. All right, so we stopped off at expectations, and we're talking about its. So its is it's just another shortcut. So as with many things in RSpec, a lot of the focus is getting things into a nice DSL domain-specific language that will let you describe the code. So in this case, its is faking this, but more accurately, it's faking this, except it takes the subject, and it would be the equivalent of running. Gotta press my spacebar. So another slide that I'm missing. So it would be the equivalent of doing expect subject.count to equal 8. And it basically just gives you the shortcut of being able to say its count is expected to equal 8. So it makes it read a little smoother, makes it a little bit less code to write. Then you can do some other things with this. You can talk to arrays, you can change some methods as well. The documentation explains it all. It gets a little bit more, again, this is one of those, it gets a little bit more fiddly. And if you're checking chains that are too deep, that's probably again an indication that maybe you shouldn't do that, or you shouldn't do it too often because you're now, you're looking deep into the structure of the object instead of just having a method on the outside. But still, it's useful to be able to do it. I've found that mostly I've been able to get away with its and like the field on the model. So run this, do the thing, execute this, verify that the model that comes back has a count of 8. So, and this is any method, so it doesn't matter what it is. And then this is the generalized specifier. This would be an example of you're doing a get in a controller, and then you can consider the response to be a side effect. So you might check the direct result of like the response code, but you can check the result, or you can check the body, but you specify, but I expect that response.body should now be equal to this. And then this is all, in some ways it is entirely subjective of what you decide you want to use here. If it looks like a side effect, try to use specify. If it doesn't look like a side effect, you could argue that response body, the result of response body is not a side effect for control execution. Ultimately. It's an example of pick the standard you want to do for your code base and then just stick with it. And of course, there are other matchers and lots more to choose from. So, raise error is verifying that this actually throws an error. And the B matcher. So this is actually executing the nil question mark method, and this is executing the persistent question mark method. So that's where Rspec will take this and slice it up and find the appropriate method for it. There's lots more. There's like range checking ones. There's start with. There's just a wide variety of matchers that you can use. You can write custom. You can write your own. Which I guess many people have talked about how that's, in most cases, that's probably not a good idea. Because you've probably gotten something that's more complicated than you need. But it is there. It can be especially useful for delivering better error messages. It can be especially useful for weird things you have to account for. An example that I've hit recently is the system that I'm building now uses a MongoDB backend. And if you put a date-time object into it, it slices off the nanoseconds that are normally in the Ruby datetime object. But it doesn't, so the nanoseconds aren't consistent at all. So if you try to compare a straight Ruby time object to a time object that comes out of MongoDB, they're not equal because the nanoseconds are different. So I've written a matcher that just ignores the nanoseconds. So it doesn't do very much. It's just enough to make it work. And that's probably a good example. It's probably an example of where you usually want to use matchers, or where you want to write your own matcher, and to try not to do anything too complicated. So this is back to the example that we had at the beginning, because now we've covered sort of all of the bits and pieces that are necessary to put this together. Any questions about this? There are an awful lot of pieces. There's an awful lot of things to do. And you can, I guess you can, I've noticed that you can get by with Rspec using just about just the things that I've talked about. There are more things. Like there are a lot of more complicated things. There's lots of options to the methods that I've already described. But again, I think in a lot of cases, if you're getting into more complicated stuff, it's probably more than, it will usually be more than, so I think almost finally. Upgrading from version 2 to version 3 is actually easier than you think it would be. So one of the Rspec team members has written a Rspec gem, which I've used, and it actually surprisingly really looks cool. And they have a really nice upgrade process. The link is there at the end. And I will post these slides. And basically the upgrade process is, it's more detailed than this, but get yourself to a green version 2 test suite. Upgrade yourself to 2.99. 2.99 deprecates all the things that 3 gets rid of. So you go to 2.99, you run your test suite, make sure it's still green. If it's not green, get it green. And then once it's green, you have an incredible number of deprecation lists. So you go through and clean up all the deprecation nodes. That will bring you approximately to version 3. But then so you clean up all the deprecation nodes, you have green test, your version 2.99, then you run the Rspec gem, and it updates everything to version 3. So it takes your shoulds and turns into expects, and it I was really surprised. It actually worked. Like on the code that I ran it on, I think there were maybe 2 places where I had to take out the change that it made because it hadn't quite worked. But other than that, it just like all of the relatively simple assertions, it actually just took them and converted them. So it was really nice. So if you have a Rspec2 code base that you need to convert to 3, it's not that bad. And so this is the links for most of the common documentation. In my last presentation, I said the Relish app documentation, which is basically a web version of their Cucumber specs for Rspec. That was really nice, and rspec.info was not that nice. Rspec.info has gotten a lot better. They've got like nice little videos that are a basic introduction to Rspec, and they've also got videos for the upgrade process, and I think a couple of other things. So it's gotten a lot nicer. So the documentation is pretty good. And finally, there's an Rspec book. I haven't read it, but apparently it's written by the team, so it's a little. Oh, yeah. I guess it must not be. Is it 3? It's probably not 3. Let's do it. So maybe not the Rspec book then. I'll take that off the list. But so that's it for the actual code. So that's it for the actual discussion. So in my previous presentation, I did have a kata that we went through and sort of showed off writing code to get to, or so we demonstrated Rspec using the kata. I have the code. Does anybody want to look at this? It's just 9 o'clock.
Sure.
So if I can, I'll show the instructions and then you can do it at home. So the idea of a code kata is it's basically it's a simple scenario where you go through and you just keep adding things to a solution and see where it goes. I guess the general idea is that it's something that you would repeat over and over again, or it's something that you might write in different languages, or something that you'll write, this month.
It's like the to-do app? It's like the to-do app?
It is, but
Example?
even simpler.
Oh, okay.
So like it would be something, I guess it's probably that it would be so simple that you could do it relatively quickly and do it over and over again. So like people will use this as like if they're doing a conference or a training on TV kind of stuff as something that you can do in half an hour. Like even a to-do app, maybe you'll spend a couple of hours having to do it to get the basic functionality. And you could still, argue about exactly how it should look or how the graphics should look, or, there's still places where you could sort of spend a lot of time fiddling. Whereas in theory, kata gives you something that is very clearly defined. This is the problem, this is what the requirements for the solution are, and you just do it. So in this case, it's a straight calculator. So start with a method, call it add. It takes a string of numbers and it adds those numbers up. And then we just keep adding in functionality like if you look on my, here, let's go to, because I do have a repository. Well, here's the idea. So it's that you start out and you move through each of the steps. So this would be your first implementation, and then you just keep iterating on that as you go, adding each more complicated step. So I do have this. So Rspec3 presentation 2015 is the slides that we were just looking at. But Rspec presentation 2013 is my old slides plus the comment. So we go in here. So you can see, so this is, I believe, the finished last step. And then if you look at the history, it has commits for each of the steps. So you can walk through and see the steps of adding each thing. So, you know, the very first one, it takes any string and returns a 0. And then we have a test that verifies that you pass in an empty string, so we don't even care what the string is, and you get a 0. So this should be, you know, this would be, no matter what, you always get a 0. So everyone can look at that. And then also, okay, so here's something interesting we can try. So this is the kata code, the finished version. Oh. So this is the finished version of the code. And what we can do is we can actually run the Rspec gem on it and watch it update the specs. So you can see this is on Rspec 2.10 right now. And again, this one gets closer. So we can look at the spec file. Verifies a bunch of stuff. And it does it using the should equal notation from Rspec3. So go to our gem file, and we go with, oh, sorry. Oh, no, that was the right place. So we're in gem file. So Rspec previously, in this, so not specifying any version in the gem, it always installed Rspec, whatever the latest version was. So the last time I ran bundler, it was 2.1.0. But now we want to do an upgrade, and we want to limit it to 2.9.0. And do a bundle update. And go have a look. It should try to pull down. So that's all simple enough that we get no deprecation warnings, and the test is still passed with the latest version, or the 2.99 version of Rspec. Now we open up the file again, and say we want to put 3.3, say 3.3.0, and it'll get the latest version of 3.3.0. We'll do a bundle update. And does the same thing again, so gets us 3.3.2 of all the appropriate Rspecs. It doesn't fail the way I thought it should. Wow.
Well, obviously the upgrade path is to just specify the new gem.
Apparently, it's way too patient and understanding. This was more brutal the last time I tried it.
Don't worry, it'll fail tomorrow.
Yeah, that's true. So there is a nice little summary of the conversions. So I mean, this is a made up example because it is so simple. But you can see there, it just went through and took the equals and turned it into EQ, and it took the shoulds and turned it into is expected to's. And we can cap the spec. There we go. So works on a very simple code base, and from my experience of one project, it seemed to work pretty well on a more complicated code base too. So I think that's all I have. Happy to answer questions if anybody has more questions. Or... Cool.